All right. Good morning and welcome. My name is Jen Guile. I'm with Endor Labs, and I'm inviting to the live stream stage this morning Matt Brown. Matt, give us a hi.
Hi, good to see you and everybody. I'm Matt. I am a solutions architect here at Endor Labs. Been in vulnerability management, cloud security, but more importantly, software composition analysis for a while now. Before joining Endor Labs, I spent a few years in those industries, but then I think a little bit more importantly, before that, I was a developer and did not love fixing vulnerabilities, but it's part of the job, you know. And now we've kind of all come full circle here. So good to meet everybody.
Yeah, since we're talking about seeing things a bit from the developer perspective in this live stream, what kind of stuff did you work on as a dev?
So
Sorry, I'm making you take
funny.
a little back.
Well, no, it's so it just bring me back down memory lane. A couple of things. It was like an environmental laboratory, and we had these buoys out on the Hudson River, and we had to do like take like pH levels and like the different water levels when the tides would change or the whatever. Those were what the environmental scientists worried about. My part of the job was it was a lot of like FTP connections, a lot of like data. So I used a lot of Java to make sure that we were receiving the data from these buoys, and it was also a lot of Python for like data visualization, things like that. Um, and right before I left, we were doing a lot with like infrastructure as code and a lot of like AI. So we actually I dabbled in TensorFlow in the beginning to kind of hope that we could see trends and things like that. But um, no, yeah, you're really bringing me down memory lane
I
here.
love it. That sounds really cool. Well, to anyone who's joining us, welcome. The format today is going to be pretty casual. Our plan here is to talk a bit about how you might, uh, what kind of vulnerabilities you might discover if you're using TensorFlow, how those could end up getting into your code in the first place. And then we're actually going to show what it would look like to upgrade from a much older version of TensorFlow, which is pretty realistic. You might have something old kicking around in your environment, to the most recent version. So I think that covers it. We're live on both YouTube and LinkedIn. Excuse me. So if you have questions, if you have comments, drop them in there. Tell us where you are. Tell us what you think. And with that said, Matt, I think I'll hand it over to you to start talking about the vulnerability that we're going to detect, what project it's in, all that stuff.
Yeah, so this is in TensorFlow. So I want to actually show a little bit about TensorFlow real quick first. Just to show like, some people may not even know what TensorFlow is. So let me just actually show that real quick. Come on, tabs, line up for me. Let's do it this way. Essentially, it's machine learning, right? Everybody is all about um, share my screen, present, share screen. There we go. I remember my first time using Zoom. Let's just talk for a second about, well, what is TensorFlow? Google is the maintainer. It's super popular, and it's essentially ways to make machine learning models, but it's all open source, and that's what makes it so popular. Is that it's available to anybody, and you can create these very large language learning models. Maybe you can create language learning models, but it's a machine learning platform. And it's actually funny. Years ago, when I was in grad school, I took a deep learning class. Shout out Pace University and Go Setters. And my professor was the developer advocate for TensorFlow. His name's Josh Gordon. So it's super fascinating stuff. We this was in 2018, 2019. So we learned about how to identify buildings. So we walked around New York City, took pictures of buildings, and we would use TensorFlow to actually create a program that would actually identify what building it was, which was really, really cool. So for those of you who don't know what TensorFlow is, that's all, it's a really powerful machine learning kind of platform that is completely open source, and a lot of people use it. So go ahead and switch over to one quick thing here. Because it's so popular, there's a lot of different components that it brings in with it. And one of those things is called baselines. And let me just pull up baselines real quick. One here. Baselines. Beautiful. Find this here. Okay. There we go. No, we get it one time. So this is baselines, and I've created a fork of OpenAI Baselines. And short and simple, it's a high quality implementations of reinforcement for learning algorithms. If you're into machine learning and if you're into kind of all this deep learning, large language models, all that stuff, it's super duper fascinating. So we want to take a look at specifically how does TensorFlow actually get into this application. So I kicked off a newer scan right before this stream. So we have baselines right here. Okay. There's 136 vulnerabilities in it, and you can see TensorFlow, but even like not directly, we have a, transitive dependencies that TensorFlow brings in a vulnerability from. So like this is in this vulnerability, this component here, but TensorFlow brought it in. They import TensorFlow directly. So there's a ton of vulnerabilities in this version of TensorFlow. This is TensorFlow 2.8. So if I actually look at this portion of it, these are the ones that we want to focus on. So they're reachable. It's a direct, it's a reachable function that's vulnerable, reachable dependency, all that really good stuff. Now, we know that these components, that this version of TensorFlow is in here, okay? Like if I do dependencies, and if I actually go ahead and do this, I can see TensorFlow at 2.8.0. We know it's in there, right? If we actually go into baselines, this setup.py, this is the manifest file, okay? No, thank you, VS Code. This is the manifest file. Nowhere here does it say TensorFlow, okay? And I'm not talking about, it's also, it could be in a transitive dependency here. It's not a transitive dependency either. TensorFlow is not brought in this certain component, this specific component. TensorFlow isn't brought in by the manifest file. It's brought in by other means. So like, how does it actually get brought in? So let's imagine, and again, you got to remember that we're going to be on TensorFlow 2.8.0. That was released back in like February 2023. So we kind of 2022, I think. Kind of go back in time here for a minute and pretend that we're in February of 2022 and we're going to be using this OpenAI baselines. And we're following the instructions. I've already done this. I've already done pip install. I've already activated my virtual environment in here. I've already done those parts, but I'm a developer that wants to use this in my open source application, okay? Baselines. So then I'm following these instructions. Now, if I do pip list, we're not going to have anything in here. We're going to have like two things, right? Because I'm in my virtual environment. My next step would be to install TensorFlow. Again, we're going to use version 2.8.0 to just, showcase and pretend like we're in 2022. So pip install TensorFlow at 2.8.0. So we'll do that real quick. Now I'm a developer.
Hey,
I'm
Matt,
following
I'm
the
gonna
instructions.
for just a second.
Yeah.
You expand, like enlarge your terminal just so it's a little bigger for people watching on like a
Oh,
smaller.
yeah.
Thank you. And pro tip,
Yes.
if it's looking a little blurry, sometimes YouTube in particular, it
Mhm.
defaults to a lower resolution. So you can always change the resolution using the little gear in YouTube.
How's that? Is this better?
Yeah, it looks better. Thanks.
Okay. If it's too small, I'll make it bigger. I have no problem updating settings and stuff. Okay, cool. So now I've installed that. All right. So I didn't use the manifest file to install TensorFlow. Like the manifest file didn't take care of this for me. I did it my own, kind of almost like externally. You can think of it like that way. Okay. So I'm following the instructions. I'm a developer. I'm like, oh, okay, yeah, this looks good. Oh, now let me install my dependencies like I normally would, right? This is more like in the build, I would say, like in CI, you're going to install the dependencies here. So if I do pip install dash e dot, following the instructions, now all these other dependencies get installed, okay? What I'm trying to kind of prove out here too is like, you're not going to be able to find TensorFlow if you just do manifest scanning. If you just look at the set.py and try to figure it out that way, you're not going to find TensorFlow. You're not going to find this version here. You got to do it. You got to do some code analysis too. So I have that. Now if I do pip list, you'll see TensorFlow. Okay. Where'd you go? TensorFlow 2.8. Now again, if I go ahead and I do this test, I have some pre-written commands that I have handy dandy here. Let's do that. Let's do that. And yes, I'm using environment variables, okay? 15, you see this? 15 declared dependencies. So where are those? Those are what these are. These 50, so you got like 1, 2, 3, 4, 5, 6, 7, 8. You got 9 direct, and then there's some transit one in there, right? So those are your declared dependencies. But remember, we're trying to find out the ones that we installed not through the manifest files. So it's saying like, oh yeah, you have 15 declared dependencies. We need to resolve the dependencies. We need to do some call graph analysis. We need to figure out, okay, yes, you wrote down or you have written down here 15 dependencies, but let's find any of the other ones that you could also have in there. So we're going to run this test for a second, and we see actually there's 49 resolved dependencies, right? Now, oops. My screen sharing just went, we got it. Bear with me. Just happened. This is the joys of a live demo. There we go. Sorry, I must have hit the wrong button. There we go.
It's only fun if there's
It's
risk,
still
right?
going here. I know, right?
There we go.
I
We
think
got
I
it back.
accidentally clicked something. We got it back.
Yeah.
So we got 49 resolved dependencies. And then you can see I'm doing a retest here. It's going to take a second. We're still scanning here. But once we have that, we're going to be able to show that, yep, I have this dependency in there. We need to fix it. And then we'll actually fix it. And it'll actually show in the CLI as well. We can just we can fix it from here and then redo a test. So now we've gotten a call graph for it. So now we know, okay, not only is my code, not only does my project have what we're calling a phantom dependency in it, meaning it got installed from some other means that you don't typically install via like a manifest file, something like that. But we also have we're also using it. So this one I'm not too concerned about. This is just the setup tools kind of thing. This one, I'm not worried about that one. So we have all these different vulnerabilities here. you can see that it's brought in via TensorFlow. So TensorFlow 2.8 has critical identified by blah, blah, blah. TensorFlow is this one, that one, right? Tons that are actually showing up in here in the output of the CLI. I mean, it's also going to show up in here too. Let me do a refresh. Okay, there's that TensorFlow, all those. So now what the tool is going to tell me to do is to upgrade to a certain version, right? Upgrade this to this version to fix this vulnerability. Now, let's say this project I was working on a couple of years ago when this version was out, but now I've gotten a kind of handle on my open source dependencies. I really want to start fixing stuff. Today, the latest version is 2.15. And to be honest, like the more Pythonic way is to always be at the latest and greatest version. That's why, in this README here, it's saying to just do pip install TensorFlow. That would just give you the latest and greatest version. Okay. So what I want to do is I want to essentially just install the latest and greatest version in here and kind of be on my merry way. So you can do that a couple of different ways. I get a little paranoid sometimes when I program. So I'll do pip install TensorFlow 2.15.0, which is what Endor is telling me to do, right? So to fix this vulnerability, I'm going to upgrade it to 8.4. The latest version is 2.15. I'm just going to upgrade it to 2.15. This is the Pythonic way kind of thing. So I'm going to go ahead, do that. It's going to uninstall or upgrade, however you want to put it, TensorFlow 2.8, and it's going to install TensorFlow 2.15.0 and see all that other stuff. Uninstalling TensorFlow, successfully uninstall TensorFlow 2.8. And any second, it will then show me 2.15.0. Beautiful. So now if I do pip list, I should see TensorFlow 2.15. So then now when I run a rescan, let's actually check. Ready? All right. 135 vulnerabilities in total. Which ones are reachable? Which ones have a test dependency? No. 13 specifically for TensorFlow that are reachable, fixable, all that good stuff. Okay. So let's see who wants to put the over under for how many vulnerabilities get fixed with this one upgrade. This whole stream is, what we've been doing this for 20 minutes. 20 minutes to fix how many vulnerabilities, I guess is the question. So same thing we're going to do again. We're going to check those declared dependencies. We're going to check for any changes that we may have. We're going to do the dependency resolution here as well to figure out, okay, which version is actually installed now? Has it been fixed? All of that kind of good stuff in here. So 135 before from using TensorFlow 2.8. Let's see how many are after. But let's look at the chat and comments if there's anything here.
Yeah, I'll jump on while we're waiting for it to do its magic. No one's said hello to us yet, which makes me a little sad to hear from people. But I do see we have people watching live, so thank you for joining us. Matt, while we're waiting for the live demo to progress, in your experience, like what's the oldest dependencies that you see on a regular basis?
Oh God. They're usually in Java.
Yeah.
And they usually are Ant, something like Ant. But what are they specifically? Probably the first one that comes to mind is C3PO. And no, I didn't plan that because we're Endor Labs.
It is a good coincidence.
It is a good coincidence. That one's pretty old. What's the other one that's like super old? C3PO is the number one that comes to mind because it has some vulnerabilities in it. It's super duper old, but it's really popular just because it's a transitive dependency in a lot of other components. But the ones where you get kind of the oldest open source components are Java, sometimes .NET, but Java I would say is the big one, and Ant. Some people still use Ant, believe it or not, which
Yeah,
is
I
just a
think there's
build.
probably a bit of a misconception that the applications being developed today are using the latest and greatest things. Sometimes what old is new, old is good. Oh, look,
Mhm.
we've got something's happened.
Yeah. Oh, yeah. So, yeah, we're stitching all the call graph together again. That's the root of the file. I'm not concerned about that at all. So then now, probably can already kind of tell, we go into projects. No more criticals. Took what, 9 minutes? Took 10 minutes to do. So we went from, what was it again, 135, 136 vulnerabilities to 5
That's pretty
from
good.
that one fix. From that one fix. So not only did we fix all the reachables, we fixed all the criticals and the highs just because of that one component. The one component brought in so much stuff that it was just creating numbers off the charts. So we can kind of see with this baseline 54 different dependencies. And actually, if we go back to our projects, go back to projects, baseline, dependencies. Let's do TensorFlow should pop up here. Now we have it at 2.15. All the info we need. So yeah, super, super effective. One fix fixes almost 130 different issues. I mean, it really is kind of that easy. Like, you got to know a little bit about Python and kind of the right flow to use Python, things like that. But,
We got a little thumbs up
you
from
know,
Anchor.
all
Thank you.
right.
Good to
Thanks.
see you here. And hi, Meg.
Yeah, it's simple. Like it's easier said than done sometimes, but that's super effective, right? You fix one thing and it fixes 130 issues. Like I just saved so much time and effort because what I typed what 3, 4, 5 words, 3
Yeah, I
things.
think
That was the
you
whole
you
fix of it.
took longer with the environment set up than
Yeah,
fixing the little thing, huh?
you're telling me. Yeah, the environment setup takes longer, but it tells you what to do. It tells you exactly, okay, this is the thing you have to upgrade. Here's the version to upgrade to fix this specific vulnerability. But if you want to use the latest version, which that's the best practice in Python, upgraded this version, you upgraded that version, it's fixed. Not only is that one issue fixed, hundreds of issues are fixed. Just makes it way easier to do.
All right.
Um,
Well, we have
I thought I
about,
was going to run out of time, but
I
that
know you did
actually,
great. I was going to say, we've got about 5 minutes left until we'll close out. So we don't have to stay all the way up to the bottom of the hour. However, we have some common, I think, questions we can cover. And then as people are thinking about the content, if they want to ask questions, drop it in the chat. So Matt, we just covered a Python dependency for a phantom dependency. Maybe you can talk a little bit about which languages these tend to be the most common with, or what you tend to see.
they tend to be common with Python and JavaScript. JavaScript's another one where, in another example, kind of where this can happen is in your main kind of code, right? Where you're actually writing your code. If I go into, let's just pick a random one and see what happens. So you see how you have your import statements here? if you are just importing something in here, and this especially happens with JavaScript too. Let me just import this component, but it's not being declared on the manifest file. Like this is where it really happens as well. This is another really common area where it happens. So more like the dynamic or functional languages. It can happen in something like Java. It can happen. I can't remember if it happens in .NET or not. It probably can, but can't say for certain. But the two most common that like we've seen are Python and JavaScript. These kind of dynamic languages where this could happen.
Yeah, whereas like Go, you wouldn't really see this, right?
No, yeah, like especially like some of the more compiled languages. It can, like I said, it can happen in Java in certain circumstances, but it's not as common. I haven't seen anyway as something like a dynamic programming language.
Yeah.
Yeah. Good
All
question.
right. Well, this session will be available on demand through our YouTube channel. Just look up Endor Labs on YouTube if that's not where you're watching from live. And then we'll answer questions throughout. Oh, look, we actually just had one come in, so I'll go ahead and show it on the screen.
Inside a function.
What if the import is in an odd position, for example, inside a function?
We'll still be able to see it because you have to do this program analysis to find it. So if it's inside of a function, that should still be okay because we're looking at the source code as well. And this is kind of the difference between just looking at a manifest file, parsing it through, trying to kind of build as best you can, and then scanning it versus doing a proper program analysis with call graph generation to say, my source code calls this dependency via this path and this call path, and this is how it gets there through these methods or functions. So even if it is in a weird position, like inside of a function, we'll still be able to identify it because we're doing this program analysis to show it. But that's a really good question, actually. It's a great question, Siobhan.
How often does that happen?
All the time. I mean, like, this is the thing about code. People, like, this is how I look at code. I need to get this thing working. And when it works, then I'll worry about making it better. But, like, I need to get it working first. And then I can kind of make it better. Sometimes I'll forget to make it better. So I'll try to do some funky stuff to make it work. And then in a different file or in 300 lines before, I'll just forget to be like, I probably shouldn't do that kind of thing. Or, maybe I can make this better by not putting it in a function or something like that. How often does it happen? I don't know the exact number, but it definitely happens. Anything can happen with this stuff.
It's a crazy world.
It is. Yeah, that's for sure.
All right. I
Cool.
think we're out of questions to answer. So, Matt, thank you. We'll be doing this again maybe in another 4 to 6 weeks. So if there are other languages that you want to see, other specific dependencies you want to see, drop it in the chat, let us know. And otherwise, yeah, thanks, Matt.
Thank you. This was great. Thanks, everybody. We'll
All
see
right.
you soon.
Take care.
Bye.